In this video, I'm going to continue showing you how to solve a system of linear equations by the elimination method. And so our objective today is that you would be able to solve them with that specific method, elimination, and then determine the number of solutions that you would have, and then and eventually we'll actually end up writing some systems and solving those as well. But in this first video, I'm going to solve the 6 problems on your notebook page 103. And so here are the 6 inequalities. Now our inequality my equations that I have, my systems that I have set up, actually have some y values ready to be eliminated right away. And so when I add my functions together, I actually notice that my y's immediately are going to cancel out, because 1y minus a y means you have no y's left. So if I combine like terms, 1x plus 1 more x is 2 x's, the total that this would equal, 15 plus 25, would be a total of 40. And now if I divide both sides by 2, I have a solution of 20 for my x. So my point is going to be 20 comma something. And now in order for me to find the y value, I'm going to sub x equals 20 back into either equation. So pick one of the equations up above. I'm going to show x minus y equals 15, that equation, and now I'm going to plug 20 in for my x. So 20 minus something is equal to 15. If I subtract 20, negative y will equal negative 5, and then if I divide by my negative 1, I'm going to get a solution of 5. So 20 comma 5 for that one. Now in my next example, I'm looking at my form. Do I have standard form? So my x's and y y's equal to my numbers. The forms are right, they're ready to go. And I actually also notice that right away my y values are going to cancel each other out here, because one is a positive 2 and one is a negative 2. And so when I add my functions together, they are eliminated, hence the name. So 3x plus 3x then makes a total of 6 x's, and that will equal 14 plus 10, or 24. And if I divide by my coefficient of 6, my x value is going to be the number 4. So for my ordered pair, 4 comma something. Now for my y value, I'm going to substitute x equals 4 back in to either equation. All right, so I'm going to pick the top one this time. It really doesn't matter which one you pick. 3x plus 2y is equal to 14. Or 3 times 4 plus 2y is equal to 14. This is 12 plus 2y is equal to 14. So to solve for my y, I'm going to subtract 12. 14 minus 12 is 2. And if I divide by 2, I get a solution of 1. All right, so we got just a few more to go. For example number 3, it says we have 6x plus 5y equals 6. And then right underneath that, 3x plus 5y equals 12. In order to get elimination, we need to have the same coefficient but opposite signs. And I noticed how my 5's are the same number, but I just need one of them to be an opposite, meaning negative. So I'm going to multiply the bottom equation by negative 1 so that my y's actually will cancel. So I'm going to first rewrite the top one here, plus 5y equals 6. Okay, now if I multiply by negative 1, this is going to be my new equation. Negative 3x minus 5y now, and plus 12. So notice how all the signs in my equation are opposite. Now when I add these two functions together, I do notice that our y's are going to cancel here because they were opposite sign. All right, so let's see. 6x minus 3x is 3x's, and that will equal 12 plus 6, or 18. And if we divide both sides by 3, we get the number 6. Okay, so for my ordered pair, my point is always going to be an x comma y. We have 6 comma something else. Now substitute 6 back into either equation, and you'll solve for your y. So here we go, sub x equals 6 back in. So let's just pick one of the top equations. So 6x plus 5y is equal to 6. All right, if x is 6, this is going to be 6 times 6 if I substitute that in. plus 5y equals 6. And 6 times 6 is 36. Now if I subtract 36, I get that 5y is equal to negative 30. Divide both sides by 5, and you get negative 6. Here we go. All right, now my next equation that I have here, the first one, is not aligning like it should be. And so what I mean by aligning, what we want is to have standard form, so your x's are in a column together, and then your y's are next in a column together, and then your equal sign is next in the column together, and then the numbers in the column. And so what I need to do is rearrange the top function. And so instead, I'm going to add my x to go out in front of that letter y. And so it's going to look like this instead. That x that I added out in the front plus the y that was already there, and now that will equal my number term 4. Now I'm going to copy down the equation that we had here, because I'll have 3x minus 2y equals 7. So now what I need to do is think about what variable I want to cancel, and then what I want to multiply my equations by. So it really kind of doesn't matter which variable you pick, but to start, you got to kind of look at, well, here it was ready to go, like 2 and minus 2, they canceled out, and here ready to go. Now here, I saw that my y's were nearly ready to go, but here neither my x's nor y's are ready to go to cancel. So I'm noticing that if I were to cancel out my x's, I would just have to multiply my top equation by negative 3. Or if I chose to eliminate my y's, I need to have my top equation have a positive 2y, so then I'd have to double the top equation. Well, it doesn't matter which one you pick, just pick one that you want to eliminate. I'll say I'll pick to eliminate y's. It's kind of been a theme already. Y. Why not just try y again? Now, if I want my y's to cancel, I need to have a positive 2, so I'm going to multiply everything in my top function by positive 2. And here's going to be my new function. 2 times x is 2x's, 2 times y is 2y, and 2 times 4 is 8. Now, if I combine my functions together, my y's actually will cancel, because they are now opposite signs, so I can combine it with the other equation that we had. So 3x's plus 2x's is a total of 5x. My y's are eliminated, and 7 plus 8 is 15. And if I multiply 5 times 3, I get 15, so that's my solution for my x. Now, for solving for my y, just substitute x equals 3 back in to either function. So I'm going to use the top one, y equals negative x plus 4, or y equals opposite of 3. I should put it in parentheses when you sub it in, but here it's going to be just negative 3 plus 4, and negative 3 plus 4 is 1, and so that's going to be our ordered pair. So here we go. We got 2 more left, the last 2. You'll see here you have 3x minus 2y equals 11, and then a function here that needs to get rearranged because I want it to align alike in terms. So the first thing I'm going to do is start aligning my functions here. So I'm going to subtract my 3y to the left side, so then it will be in the right order. So if I leave my first function in the standard form that it is, and if I subtract that 3y, I'll have my 4x first, because I want to align my terms, minus a 3y, and equal to the number 14 then. Now, neither of my variables have coefficients that will cancel. So 3 and 4 don't cancel each other, and 2 and 3 don't cancel each other. So again, in this case, you kind of get to pick, kind of like we got to pick in this one, which letter you want to eliminate, and then you're going to have to multiply your equations to make them the same coefficient so that they will be eliminated. So let's say I choose to eliminate x. And in order to get these to eliminate, I need to multiply both functions by a number so that they will have the same coefficient so that they can eliminate. So the first multiple that 3 and 4 have in common is 12, and so I'm going to multiply my functions by a number so that they will become 12s. And then I also want to multiply so that one of the functions will have a negative 12. So one should be a positive 12, one should be a negative 12. All right, so I'm going to do a couple different colors here just to kind of help you keep track. I'm going to multiply the top function by 4, and I'm going to multiply the bottom function by, because 3 times 4 is 12, the bottom function by negative 3. So the top equation will have a positive 12x, the bottom one will have then a negative 12x, and then our x's will become eliminated. So here would be my new top function. So 4 times 3 is the 12x that I wanted. 4 times negative 2 is negative 8 for the y term. And 4 times 11 is 44. Here will be my new second equation. So 4 times negative 3 is negative 12, which is what I needed for my terms to eliminate. Negative 3 times negative 3 is positive 9y. And 14 times negative 3 is negative 42. I had to use my calculator for that one. Now my functions have coefficients that when I add them together they should be eliminated. And that coefficient this time here is my 12 and negative 12 in front of my x terms. Alright, so if I add my functions together, my x's cancel, I'm left with 1y, and I'm left with 2. Oh man, that was so great that we picked that because look, we solved for y. We didn't even have to divide by a number. All right, so my y value is 2. Make sure you put that in the y spot of your point and not accidentally in your x. Now let's plug 2 back into either original function and you can solve for your y. I'm going to use the bottom function this time, and I'm going to go with, let's see here, 4x is equal to 14 plus 3y. Now I'm going to sub that 2 value in for my y. So 4x is equal to 14 plus 3 times 2, or 4x is equal to 14 plus 6. Well, 14 plus 6 is 20, and 20 divided by 4 is my solution of 5. So then we get a 5. All right, this video is getting long. Hang in there. We got one more left. Go ahead, you try. Pause the video, try it out for yourself, and then see if you get the same answer that I do. You can even fast forward through my explaining if you want. All right, hey, welcome back. I'm so glad you tried that problem on your own, like a pro. Okay, I'm gonna start here, and maybe you solved for a different variable than I did at first, but I noticed that I can do in one move, multiply my second equation by the number 4, because then I will have a negative 20x, and that will cancel with my positive 20 from my top equation. So here's my new second equation. It's going to be negative 20x plus 16y equal to, oh, I don't know, 53 times 4. It's going to be 212. And now I'm going to just recopy my first equation up here, positive 20x plus 10y equal to 100. And now these two functions are ready to be combined together, and I notice that my x's are going to cancel. Okay, so let's see here. Those cancel out. I'm left with 26y will equal 312. It's definitely going to need my calculator. 312 divided by 26, oh, it's 12. So now what I'm going to do is sub 12 in for y. Pick either equation, it doesn't matter. I kind of think the top one looks good. So 20x plus 10 times 12 for the y will equal 100, or 20x plus 10 times 12 is 120. That equals 100. Subtract my 120. I get 20x is then equal to, all right here, negative 20. Divide by 20. My solution for my x is negative 1. So here's our point. X value of negative 1, y value of 12. How'd you do?